My name's Tyler Clemens, and I'm a major in ASM.
I'm Derek Leahy. I'm a major in ASM.
Justin Lambert, dual major ASM, handle agribusiness.
Well, Justin, what is the title of the project?
The title of the project is Bunk Scraper Attachment for a Bunk Sweeper. So, I worked at a feedlot this summer down in Dalhart, Texas. And the problem we had is they just came out of a 4-year drought and they began to get precipitation, which was causing the feed to soak overnight, and then it would dry all day in the bottom of the bunk and basically cement itself to the bottom of the bunk. So the problem we had to find out if we could fix is if we could develop a mechanism that would scrape the bottom of the bunk.
How large is this feedlot? Because I'm looking at the picture thinking, well, if it's a feedlot, just take this shovel and clean it out. But how long is it?
There is about 40 miles worth of bunks at the feedlot. 76,000 head was the size of the feedlot I was at. Generally, the way we're doing it now is scraping out by shovel, and that takes about 5 hours out of your feeding time every day.
Okay, so it's a significant labor problem.
Yes.
Were there other solutions that they used before? Or how did they deal with feed refusals by the cattle?
Honestly, the only way that they have been doing so far is by just scraping out the bunk. They do have a sweeper that sweeps out loose feed, but the bristles aren't strong enough on the brush to sweep out this hard-packed feed.
Is that thing that sort of looks like a car wash there?
Yeah. This is a trailer sweeper that's pulled behind the tractor on the hitch mount. This is an arm sweeper that actually mounts to the 3-point hitch and is hydraulically controlled.
Okay. Well, I'm looking at a solution. I kind of see over here an AutoCAD drawing or some kind of CAD, and then I see over here. It looks pretty similar. Derek, explain the design to me. How did you come up with this?
I came up with the design from, we tried to try to make it universal, to be able to fit in separate different feed bunks. So when we're coming out with the sliding arm, depending on what tractor size you want to put it on, it helped out with the length of the wheelbase as far as, and for up and down use, we had it so it'd be able to float over the bunks, and also you can adjust it from there for depth as well. As you can see on the back end, it's a little different. I did struggle a little bit with AutoCAD design, making a flat plate in the back, and the cultures as well. But other than that, it is mostly the same.
Yeah, it looks very similar to what you drew. I see some adjustments up there, side to side, adjustment here, up and down. What's the role of the coulters?
The coulters is supposed to be for a guide base purpose in the feed bunk. So it's pretty much just to flow and keep it off the walls.
So the driver doesn't have to be an A+ driver?
Correct.
Can a B- driver make this thing work?
Absolutely.
Yeah, just wondering. And is this a video of it working?
Yes, it is.
Can we just see a little bit of that? So how fast are you driving there approximately?
Right now, it's about a mile and a half per hour.
And that didn't clean the bunk, it just scraped the hard, crusty stuff?
The idea behind this is there will actually be a sweeper mounted behind this. Okay. This just attaches to the 3-point mount for the sweeper.
Okay.
And so there will be a sweeper running back here that the feed will flow over and back to and be kicked out.
Very good. And this was just a mock-up. You're not really wasting that much feed, are we?
No, this is old used feed that they didn't. But you can see here, I mean, you get a nice clean bottom under the loose feed. So.
Well, Tyler, see some economics up there. Tell me about what's this thing cost? What's the payback? What's the analysis there?
So before we came up with this design, like Justin said before, they're using manual labor. So as you can see on our poster here, it usually took about, they had 5 workers going at one time, and they were paid $13 an hour. You usually worked on it for about 5 hours a day. So if you do the math, we figured it up per year and or per week, and it comes out to about $1,600 a week in labor costs that they had. So with this new design, we've got if you were to buy it, it'd be around $1,000. If you take your workers out and your labor out, we figure out you save around $240 a day, which is a pretty short payback.
It's your dad on the phone, and what he wanted to know is, what did you learn at Purdue that helped you do this project? Here, I'll just let you talk to him.
Okay. Hello? Yes. Yeah, it was all the technical designs and all the prereqs that you got to do, and all the measuring and just the precautions to get there, as well as the CAD work helped with that, and then getting it out there and testing it, and then just all the mechanical modifications that were needed to do.
He also wondered if I'll be right back with you, Mr. Clemens, just a moment. He also wondered if you had a job after you graduated.
Yes, sir.
And Justin, did you have a job after you graduated?
Yes, sir.
You did?
Yes, I did.
Well, we're here at Purdue Ag and Biological Engineering. We're in the ADM Ag Innovation Center, and here is a set of ASM senior students with a challenge solved.